Everybody, just thanks for joining into this Petrosys webinar. Please make a note that we are recording this, so we'll stick it on the website a little bit later in the next couple of days. Like I said, thanks again for joining the Petrosys webinar. This one we're going to be talking about editing contours, faults, and polygons in Petrosys. So this is a really handy tool for being able to go in there, let yourself or whoever the interpreter happens to be go in and make some changes and really have a lot of influence over your surface models. Please feel free to send some questions through the little question chat, and I'll either answer them if I see them pop up, or towards the end here I'll open up everybody's mic and you can ask questions if you need to or you have anything. So without further ado, the main things I'm going to be talking about today are going through and actually showing you how to add some control contours to sparse data sets. So in this case, we're going to use an example of some 2D data, so you can have a lot of big kind of open areas. Adding control contours is going to help guide the surface model. Then we're going to move on, pick up a 3D seismic data set and show you how to add some fault polygons in there to use as barriers to the gridding process, and finally use a tool called localized regridding, so you can actually go in, take a grid that you've already created and actually replace a small section of the grid with your own interpretation. And then I've just got a little picture here, screenshot. This is the toolbar for the CFP editor. That's the Contour, Fault, and Polygon editor. I'll probably just call it the CFP editor from now on. And then just as an example, this is kind of a starting point. So we've gone through, just gone in, gridded your data up, so 3D seismic data set, and it can end up being a little bit noisy. It's a little bit of things that you might end up wanting to change. So I'm going to show you ways to go through, make some edits, replace a section of your grid with the your own interpretation, maybe smooth things out, add some faults in there, and really just make it look however you want it to look. So that's really all the PowerPoint I have. I'll just jump right into a nice little Petrosys demo, and of course I'm going to be using the latest and greatest version of Petrosys. That's version 17.2 SP6. We're going to see a couple little changes to the Contour, Fault, and Polygon editor. So if it's something you've used in the past, hopefully you'll see a couple little new tweaks that have kind of improved the editor itself. So let me just open up a map canvas and a surface modeling window here. In the map canvas, I'm just going to pop open a DBM or a map file that I created previously. This is going to show you my 2D data set. So this is kind of my starting point. I'm just showing some 2D seismic lines with the ribbon map being displayed. So as you can see, we've got some data, but there's not a whole lot of data in between, or there's really no data at all. So Petrosys, if we only use these lines to create a grid and contours, Petrosys is really just going to try and guess what should be happening here. It's going to try to extend whatever trend it sees, but sometimes there can be a couple little issues. So adding some guiding contours can really help that out. So let's just grid this up so you can kind of see where we're starting from. And I actually have a gridding task that I'd created previously that has a couple steps in it. This is just a really simple grid create grid task. So that option is just grid create grid. It's going to go in here, specify my output. My input data is really just this 2D lines from my SDF. Everything else is pretty basic, really large cell size based on the fact that my 2D lines are pretty far apart. So it's going to be about 1,000 by 1,000. Spacing, method, standard gridding, minimum curvature. I've turned off just about everything else, the faults, clipping, smoothing, and reporting. We're not using any of that, but we are going to create some contours. It'll be a lot easier if you just see changes in the grids whenever I show you the contours. Quick little tip here, if you haven't ever noticed this before, in the surface modeling window, if you have the tab active, so if you're using faults or clipping or one of these other ones, it'll get a little asterisk next to it, so you don't actually have to click through and look at each individual tab. You can just refer to, hey, if I've got an asterisk there, that means it's turned on. So I'll just let this guy run, replace some old files that I made. You can see that went really quickly here. And in this case, I'll just turn that guy on. And so once we've turned that on, you can see it's done a pretty good job actually of filling in the spaces. Nothing too crazy going on outside of the data set. But let me pop open a little Polygon here. We can see there's a couple little problems that I'd like to correct using this contour control points. I'm going to fix it up so that we don't get this little artifact here. This is actually being caused not necessarily by a lack of data, but because there's a little bit of a mistie in the data here. If I zoom in, you can see the values don't tie perfectly where there's that crossover between the lines. And then you get over here where we just didn't have any data. Let me move it so it's more in the middle of the screen. Where we didn't have any data, it is kind of creating a little basin here. But let me turn this. If you turn the grid off, you can see there's really nothing indicating that this should be a basin. So I'm going to add some guiding contours so it just extends kind of the anticlinal structure and removes this basin here. So to do that, I'm just going to turn off my polygons, kind of zoom into this area over here, and move into place. And now I'm going to get into the contour fault and polygon editor. To get in here, I can just go to Edit, Contours, Faults, and Polygons. I click Open. Go in here. I'm just going to right-click to clear out the old files that I had been using. Now, I'm going to actually create a brand new contour file. So I'm just going to give it a brand new name, call it 2D Seismic Control. This is just going to make a blank file, so it doesn't actually have any contours in it yet, but it will. And after I start adding them into it, this is a really nice way of, if you need to, say, digitize some contours, or go in and just start with a clean slate and draw contours in here, make your own. You just put a new name in there, and it's going to create them. So I click OK. Then you're going to get prompted for the display preferences. So whenever I draw my new contours, or if I draw a new polygon, or have my polygon faults being displayed in the editor mode, the default settings here are to display them just with black lines, but I've changed that so that they stand out a little bit more. I'm going to be showing my contour lines, the new ones, with the blue. Polygon lines are going to be showing up in orange, and the polyline faults are going to be showing up with green. If you've used this tool before, you might notice a little change here. That's this stream editing mode. We've recently, I think in actually version 17.2 SP6, added the option to use this streaming mode. It's designed to work with kind of a tablet input device. So if you have sort of a tablet that you can display Petrosys on, and then you can kind of use a stylus as an input. They call them the Wacom tablets. These are designed to work with. That streaming mode lets you use that just like a drawing tablet, so we can just trace over the lines that you've got on there. If you have, say, a georeference tip image or something that you need to trace, turn that streaming mode on and you'll be able to trace them using one of those fancy tablet inputs. Otherwise, we can leave it on. It still works if you just have a mouse, and it kind of keeps me from having to click too much. So if I click OK, now we're in editing mode. First thing that pops open is my nice little CFP toolbar, and something that you can notice whenever I hover over these different tools, it's going to tell me exactly what that tool does. So that's a pretty nice little handy thing if you have questions about it. I'm going to go through some of the tools. I won't be able to go through what every single tool does, but there's a really nice help topic on the CFP editor that goes through what everything does here. And of course, if you ever have any questions, you can send them to Petrosys support, and that will we'll get back to you very quickly. In this case, we just really want to create or extend contours. If I click that on and I've got the streaming mode on, you get kind of a new input window. Really nice new feature here is being able to set the contour level and set the increment, so I can draw many contours over and over without having to specifically type in the value every single time. In this case, we're going to start out at actually using a level 630, so I can drop that down. I can type into here, so if I wanted to start at 600, I can type that in, but in this case, we're going to start at 630. Let my increment be 10, because I want my contours to show every 10 milliseconds. It's 2A time. And now I can just go ahead and draw them. I'm just going to trace the 631, so I can just click on my left mouse button and then trace around. So you can see this is a little different than it used to be because I don't have to click around. If you have a pretty steady hand, then I can double click at the end to finish it up, and I've drawn my contour. If I want to go on to the 640, I just click on the little arrow here, jumps up to 640. And this time I'm just going to trace this 640, a little sloppy here, but it doesn't have to be too perfect for this demonstration. Finish it up, double click, and now I've got my 640. And now the 650, this guiding contour is really the one that's going to kind of smooth this out and kind of adjust this area right here to remove this portion. But of course, you can always come in and really contour this up for real, you know, by looking at the data points. But I've been messing around with this for a little while, so I kind of know where the lines are supposed to go. But you can see there's my data values at 650. If I want to add a guide, I can draw that right in here. So I can have my 650 line go right to about there. If I don't want to double click, I can click the Add Contour button right there, and it adds a new one. Then I can actually add another one here. So I'll add that, add contour, and then we'll just put one more over here as a nice little guide. Okay, so those will help guide my gridding process over here on this side. And now we're going to move down to this lower area. Let me just scroll up here, and I'm going to add I really probably just need to add a couple here. If I zoom in, you can see the values are about 785, so I'm going to add a 780 that extends a little further up, and then an 800 to help guide it a little bit more. So click back on here, on my Create or Extend button, go to, actually we'll say 780. I'm actually going to bump my increment up to 20, and then this time around I can just really draw this out. So I want it to kind of extend straight up to there. We're going to come down through to about here and actually loop back around. And then I'll move on to the 800, which I want to run pretty much parallel to this one. If I stop, and then the next time I click, it's actually going to extend the contour. So you can see I can actually still click, and it's just going to basically spline the points together. If I make it kind of jagged, I can actually increase the amount of compression going on to make it a little bit smoother if I need to by adjusting this while I'm still editing it. So as long as that contour line is red, I can adjust the amount of compression, and you can actually see how many different vertices are being used or not there. Alright, so I think those two contours are going to work pretty well. Click Add Contour. So now I've got my 800, my 780, got a couple guiding contours. Let me move these out of the way so you can kind of see what I've got here. Hide my originals. So these I'm actually going to use. So now I can use these contours as extra input to my gridding view along with the 2D data. So if I click Close there and just get out of my editing mode by closing this window, it's going to save into my new contour file. Go back to Petrosys Surface Modeling. I've got a secondary task here. This one, I've added in my 2D data as well as that new seismic control contour. I don't need to edit before gridding. Otherwise, everything is set up the same. My geometry is still 1000 by 1000. Method still standard gridding minimum curvature. I've changed the name of my output grid so I don't overwrite the original. Contouring is the same. So if I click OK and let that one go. Now if I go back, I can turn on my corrected structure, and now you can see, first off, let me pop on the polygon so you can see these are the two areas that I was wanting to correct a little bit. If I zoom in onto this little high structure, we can see it's adjusted that. Kind of caused a little problem there where I bumped my original, or where I moved my contour out, but I could always fix that a little bit later. But we've removed that little artifact here, and we've helped guide the contours where there was this bit of a mistie. If I move down to the this other section and zoom out a little bit. We can see I've removed that kind of extra basin area that was created here and created a much smoother kind of anticlinal structure that we're seeing. That's really what it should look like. We don't want it to add extra structures with no data in there. So that's just going through, adding some extra contours, using those in addition to the originals, the original 2D data. So that can be pretty nice and handy there. It is, a way of influencing, going in and completely influencing your actual data. So you have a lot of control over what Petrosys is going to end up doing. Let's switch over to a map that is using some 3D data. And when I do that, I'm connecting actually out to a kingdom project here, and this time we've switched over. This isn't the Petrosys grid, this is actually the interpretation data coming out of the kingdom project, just being displayed on the same map area. But we can see that the data is really covering a lot more of the grid area. So what I want to grid, there's a lot more control because the data is much more densely spaced. If I go through and just grid this right up, and actually let me go back to my surface modeling. I've got a previously saved 3D task here, and you can see I'm just going in, gridding up my SMT seismic data, just make sure I'm connected to this Teapot Dome project. So that's all connected, looking at the correct horizon. Make sure my geometry is the same. You can note that I've changed my geometry so that it's a lot finer cell size. We're dropping down with 3D data. You can go down to a much smaller cell size. So I've gone from 1,000 to 100 by 100. I'm also going to clip this, so I don't want it to extend out too much further than my actual data, so we're going to clip it. Otherwise, we're not using anything else other than contouring. No faults, no smoothing, nothing else there. If I let this one run, basically let that go. And now, if I turn that guy on, so this is the structure that I just went ahead and created. You can see it's just a little bit noisy, and I'll zoom in a bit so you can see a little bit better. It's definitely a little noisy, which is a common occurrence whenever you're working with 3D data. There's just a whole lot of data points, and if the data is not really smooth, the grid's not going to come out very smooth either. Not necessarily a bad thing, it's just a fact of life. So I'm actually going to go through here and make a couple changes. First, let me zoom into this specific area here. But the first thing I really notice is we've got these contour lines that are coming through and kind of, really quickly changing direction. We've got a big change in dip, or the slope's changing pretty drastically right here and right about here. If I turn my grid off so you can see the interpretation, we notice that the interpretation is actually missing in a lot of these areas. That's probably because we should have a fault right here, or there is a fault here. A lot of cases you're going to be able to import your fault polygons over from SMT or from whatever third-party source you've got that you're connecting to with Petrosys. Otherwise, we can draw our own polygons in here. So I've got a pretty good idea that there should be a fault in there. I can go in, use the same tool, edit, contours, faults, and polygons, open, get rid of my contour file that I was using previously. I'm going to actually create a new fault file. This is creating, or actually picking up an old fault file, but I'm just going to overwrite it so I can draw some new guys in there, some new faults. I click OK, click yes to overwrite, click OK to my display parameters. Now you'll notice there's my handy dandy Petrosys CFP editor toolbar. I'm going to click that first button to create a new fault, and then same kind of window here. This time we don't get to set an interval because the fault doesn't necessarily have a numeric value, but we can specify the fault name. I'll call this guy fault A, and then I'm just going to kind of trace along and draw where we're missing the seismic data. And I'm not being super careful here trying to go a little quicker than you might normally do it. I can click Add Fault, and there you go. Now I've got a nice green line that is covering this area of missing data. Let me change the name here to B, draw another fault in. Just holding down the left button and tracing along with my mouse. I'm sure this would be very handy if I had a nice little Wacom tablet to use as an input device, because then I could draw it. It might be a little bit smoother, but that's okay. Alright, so there I've got another fault here, and let's finally add one more just above that one. Call this guy C. And so I'll just wrap that around, double click, and there we go. So now I've got three nice little fault polygons. Actually, this polygon seems to have, let me hide some of these other data so you don't see everything there, and I can hide that. You can actually see I kind of missed a spot there. Let me just close that up. So there's a nice little tool here to close a non-joined object. If I click on that and select this polygon, click on it twice, and you can see it filled it in. So now it closed it up, so it's a nice little closed polygon now. Alright, exit out of the editor, click OK to save. Yes, yes, yes. And now I'll redisplay my structure. If I go back to my surface modeling, go to the Grid Create Grid, that's the original task. I'm just going to turn on the faults, so use fault data. I'm selecting that same fault file that I just created. Make sure I got the right fault group. If you created a new surface or new groups, then make sure you choose the right ones here. I'm choosing to just blank inside of the faults, so you have the option of turning on gridding inside or not gridding inside the faults. Click OK there and let this guy run. It's going to overwrite my original file, the one that we're looking at right here. Create some new contours, and all done. Now if I go back, refresh the view, we can see we've added the faults in here. And so you can actually see that if I just turn off the grid, you can see the contours actually just stop. They come to a dead stop right where those fault polygons exist. So instead of having the contours kind of loop around and kind of swirl around the faults, we've just basically said, hey, there's a break here. It's all right that the z-value changes are pretty drastic from one side of the fault to the other. This is a nice barrier, this fault. So have the contours just come to a nice smooth stop at that fault edge. So that's a little bit better. We still, I might think, hey, this is a little bit noisy. I'm going to just go through and clean it out. Or, I've got a better idea of what this interpretation should look like. I'm going to go in. I'm actually going to draw some contours in here and just completely replace this kind of structural high with my own interpretation. To do that, I'm just going to basically turn off the grid. I'm actually going to leave these faults on. Turn my faults back on. I'm actually going to leave these contours on just to help guide exactly where I want to make the changes. But go back into my contour, fault, and polygon editor. This time around, I'm going to choose a contour file that I'd created previously. We could go through and do the same thing I did before, where I draw brand new contours. But we already know how to do that. I'm also going to create a polygon file. This is going to come into play in the actual grid process. We need to have a polygon file to point to whenever we say, hey, which section of that original grid do I want to replace? So I'm going to create one right now. And then we're going to use the fault file because I actually want to do something that's going to interact with this fault file. And it's going to help me create a good polygon for use in that localized gridding process. So you can see here, I've gone through a little bit earlier and created a couple guiding contours, or actually these are more like a replacement contours, so I'm going to actually replace my input data with these contours in this small area. They don't fit exactly with my brand new faults because those faults look a little different than how I drew them earlier before you guys started watching me. So I'm going to do a couple little edits to these contours. So that's a good thing to see that you can do. So I basically just want to clip the edges off so that the contours don't go into the faults. So I can use this little cutting tool to basically select the object I want to cut and then snip it, and you can see a small X that's appearing wherever I want to cut these things. I'll clip this guy right here too, clip this one, and now that I've cut them, that means there are multiple contours instead of just one smooth line. Now I can select them to remove them. So I can use a little trash can tool to select an object and then get rid of it. Highlight it so it turns red and then get rid of it. Remove, 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 and that's good there. As you can see, I am editing just these blue contours. I can turn off those originals that I was using as kind of a guide. And now, let's say I just want to snap these contours, or I do want to extend them a little bit further so that they go right up to the edge of the faults here. If I do that, I can say, all right, the 650, move that down to about there. Let's change my increment to 10. Use the arrow to change that to 640. Move that to about, 650. I didn't finish creating this one, so if I click Add, that finishes it up. Go back down to 640. Draw that one. Add contour. Here's my 630 contour, so I'm going to drop it down again. I want to extend that. Add contour. Add contour. And then so on and so forth. So I can actually go over to my 650, extend that guy down, and those look pretty good to me now. So I click Exit, get out of there. So now I'm not adding any new contours. I can actually take these contours, and I want them to come all the way up to the edge of the fault. There's this tool here, Snap to Nearest Fault. I can use that, and actually it's got a pretty small radius of effect, so I'm actually going to expand that. You'll notice there's a little circle. That circle is the area that it's going to actually affect, or the tools are going to affect. So if I right-click to get out, then I can choose this to change the proximity circle. Just hold down the left button and make it a little bit bigger. Now when I use this tool, you see I got a bigger circle. I can click on this fault and snap it right up to the edge, or snap this contour right up to the edge of the fault. Whoops. So, pretty nice and easy. You also notice I didn't quite connect those two. If I wanted to connect two portions of the same type of object, but they're not the same object, I can use this little snap together tool and say, you know what? In fact, I think I messed up creating this one and closed it so it's a tiny little circle. If I zoomed in, I'll actually just remove that and draw a new one. And now, if I want to snap these two guys together, we can do that. So make sure it's just one line, and there we go. And then I can also snap that right up to the fault. Let's move over a little bit and finish up here. Snap that guy on there. Alright, and so now this looks pretty good. I'm actually going to add one more little guiding contour in here. Okay, so now I think that looks pretty good. So now let me compare that to my original. Yep, so this guide's it's pretty close. It's just going to be a lot smoother, so you'll really be able to see the difference here. Now I need to create a polygon. So I'm going to draw a polygon around just this area to make sure that whenever I click regrid, I'm only going to do it within a certain polygon. I'm not going to just hand draw the entire polygon this time around. I'm going to use something called build a polygon out of hand-picked lines, faults, and contour segments. That lets me basically trace. It's going to automatically trace the edges of, say, these faults, or if I had this closed contour, I wanted to trace that and just turn it into one side of a polygon, I can do that. But that's the tool to use here. I'm actually going to do this. It's going to be a little bit fine-tuned, so I want to make a pretty small proximity circle. And now if I pick that tool up, we can see I can basically select a point on this fault. You'll notice that it's highlighted in red. And now if I just click on another point, that small section of it turns pink. That means it's tracing along there. So this is my hand-drawn polygon. So if I trace this guy around a little bit, let's move out a small portion. Let's say I wanted to trace along just the edge of this contour a little ways. Can do that just by clicking on it. Let's move down a little bit so I can see my working area a little better. And then zoom in. And I'm actually zooming in and out using the mouse button, so if you're using a newer version of Petrosys after version 17, you can do that too. And then just clicking through here. So then again, I've selected the edge of this fault, traced along that edge just a little bit, and then clicked again. And so then I just want to trace along that fault, go on over to this guy. So you can see this can kind of speed up the process a bit, because I don't have to click along and trace every single point. I can basically just click on the object I want to trace and then click a little bit further down, and you can see it makes a nice smooth line right there along the edge. So I'm done creating that polygon. We're going to just call it regridding. And there we go. So now it's created this nice little polygon. You can see it in orange there. And if I zoom out, so now I can use this polygon to specify, hey, I want to regrid, but only regrid inside this area. So it's a small area compared to the entire grid that was created previously. So let's get out of here, say OK. We're going to save some things. Now if I go back to my surface modeling window, go in, I've got a new task. This time around, creating a new grid, calling it 3D Seismic Control. So this is basically going to take my old grid, and then I'm going to use something called localized regridding, and it's going to replace just that small area that I just made the edits to. You can see it's a little different from my previous task because my contours are the only input data I've got. Geometry, sticking this to the same geometry. Under the Methods tab, this is where the big change happens. We'd originally picked standard gridding. This time around, we're going to pick something called localized regridding. Otherwise, same gridding algorithm, same bicubic interpolation method. This time, we picked the original grid, so this is the grid that we created using the 3D Seismic, and we're picking that polygon file that I created just a second ago. And then we're going to regrid inside that polygon only. We're also going to utilize that fault data that I had before, the clipping, stick with the same outline clipping, and do a little bit of contouring. Click OK, and let just this task run. You can see I popped open the sample data file editor, so we can see my only inputs are those contour lines this time around. And what it's doing is basically creating a grid using just these contour lines as input, and then it's applying this small area to the original grid. Go back over to my map window, and I'll just turn off the original structure, turn on my new regridded structure, and you can see it's actually the same everywhere except for where I made my contour edits. So in the case of where I've edited the contours, it's replaced this section of the grid with just that input. And it works really well if you need to just replace a small section. So if I need to make little corrections to the grid, we can do it. I actually did it over a pretty big area this time around, so you can really see what's happening. But you can do it over pretty small areas if you just need to make small changes. And you didn't want to just smooth the entire grid. I've actually even gone through here and created a difference grid using grid arithmetic. So I go back to the surface modeling, you can take a look. This grid arithmetic task is just subtracting my original grid from the new grid. And if I let that one run, I can go back here, turn that difference grid on, and you can see where it's yellow, the value is 0. So there's a 0 change between those grids everywhere except for this small area that I made these edits to. All right, so now I'm on my way to making a grid that I'm going to be able to utilize to make new maps. I can, I've got some faults in here now. I've corrected some of the structure. I can plug this into other grid arithmetic operations, use it for a time depth conversion, go into Petrosys volumetrics tools and calculate volumes on a depth converted grid here utilizing this. But it's a really handy tool, that localized regridding. If you're happy with most of the grid, you want to make a couple little changes here. So let me just pop back on over to our PowerPoint there. That's pretty much the end of the demonstration. Just to kind of reiterate what we did here, I've gone through, used the CFP editor to make some hand-drawn contours. Those added some control to my 2D data set. We added some faults and polygons pretty easily. You can just use this new streaming mode to kind of trace along, make nice smooth polygons. We can also use that hand-picked mode to trace other faults, polygons, or contour lines to make a new polygon for use in clipping, or use that in the volumetrics workflows. And then finally we showed you how to do the localized regridding process, so we can go in, use localized regridding to replace just a small portion of the grid using some new input data instead of having to just accept whatever the first run is that Petrosys goes at it. And you can actually use localized regridding for things other than your own hand-drawn contours. You can use any input there. So if you have, say, a big regional 2D grid, 2D seismic grid, and you have a small area that you wanted to replace with some updated 3D seismic survey interpretation, you can actually use localized regridding to only regrid a small section of that. So you can do this as kind of a way of doing grid merging, or it's another option there. Or if you have well data that you'd prefer to use in certain areas in preference to your seismic data, you can do that and come up with all kinds of different ways of fixing up the grids that you'd previously created. All right, so that's about everything I wanted to show you. Thanks everybody for sticking in here and listening to us, or listening to me talk about it. Definitely, if you have any follow-up questions, you can always send those to support. Any other kind of information, you can always send questions to info@petrosys.com.au. We've also recently started putting different things on the social media. So if you wanted to follow Petrosys, see what's going on with new versions, new releases, when we're doing these new webinars, definitely start following us on Facebook or Twitter. That's at Petrosys Info. It's really handy to join up with that Twitter feed because we do put a lot of little how-to videos, and we always announce, or we've been announcing the service packs that come out and other things that we're going to be working on. So whenever we go out, trade shows or anything like that, we'll always put stuff on Twitter. Otherwise, you can always check out our website, www.petrosys.com.au, for updates. So I guess I'll leave it open if anybody has any questions about these workflows.